Now we have to discuss about the reversible and irreversible cells. There are two conditions, and if any cell follow that conditions, that is called as reversible cells, and does not follow that condition, that is called as irreversible cells. Then we are going to discuss about reversible cells. A process is thermodynamically reversible if first condition, driving and opposing forces, driving and opposing forces differ by an infinitesimally small amount, and any change taking place can be reversed by applying opposing force infinitesimally greater than the driving force. These are the two conditions, and when any cell follow these two conditions, that is called as irreversible or reversible cells, and the cell which does not satisfy these two conditions are called as irreversible cell. Once I repeat these two conditions, a process is thermodynamically reversible if driving and opposing forces differ by infinitesimally small amount, and any change taking place can be reversed by applying opposing force infinitesimally greater than the driving force. These are the two conditions for reversible cells, and those cells which does not satisfy these two conditions are called as irreversible cell. Then explain these two conditions with one of the examples. That is, if these requirements are satisfied by the cell is reversible, and if these requirements are not satisfied by the cell, that is called as irreversible cell. Then we have to take this, or to verify this, the cell is connected to external source. The cell is connected to external source of EMF, and there are three conditions. One is, if external EMF is exactly equal to cell EMF. External EMF is exactly equal to cell EMF. In that case, no current should flow and no cell reaction can occur. The potential difference आता झालं
मग मी किती उशीर येऊन गेले धक्के सर घेत होते
बरं सगळं तुम्ही घेता सुरायला एक सर मला
असू दे की मी घेते की किती वेळ लागेल सर
एक 10 मिनिटं
बाबा
हो
आवडते
हो then if external EMF is exactly equal to cell EMF, no current should flow and no reaction should occur. Therefore, in that case we say that the resulting potential difference is zero current potential. Second condition, if external EMF is slightly less than cell EMF, small current will flow from cell to external source and the cell reactions occurs. And the third condition is that if external EMF is greater than or is slightly greater than cell EMF, then in that case the current will flow from external source to cell, that is current is reversed, and the cell reactions are also occurred in this case are also reversed. we can explain these two conditions with the help of example, that is Daniell cell. Daniell cell is the reversible cell, and in that case liquid reaction potential is separated or eliminated by solving of porous part. Then in that case, if Daniell cell is like this, ZnSO4, that is salt, then these are separated by another salt and copper. This is the example of Daniell cell. In the Daniell cell, if external EMF is slightly less than cell EMF, that is Daniell cell, the cell reactions occur in that case is Zn gives Zn2 plus aqueous plus 2 electrons, and at oxidation of reaction and reduction of reaction, Cu plus aqueous plus 2 electrons gives Cu solid. This is the at reduction of reaction, and the overall cell reaction is that Zn solid plus copper ions in aqueous state gives Zn ions in aqueous state plus copper. These are the cell reactions when external EMF is slightly less than cell EMF. If external EMF is slightly greater than cell EMF, then in that case the cell reactions are, that is at oxidation, that oxidation of reaction is that the cell reactions are reversed. That is in that case aqueous plus 2 electrons gives Zn and Cu, is correct. At oxidation, at reduction of reaction, this oxidation, reduction of reaction and oxidation of reaction, if external EMF is slightly greater than cell EMF, then cell reactions, these cell reactions are reversed. That is, Cu gives plus 2 electrons, and the overall cell reaction is that like this, plus Cu gives zinc in solid state and copper ions. That is, the cell reactions are reversible, therefore the cell is reversible. Then second cell is irreversible cell. In irreversible cell, we already told you that the cell which does not satisfy these two conditions are called as irreversible cell, and this irreversible cell can be explained with the help of Volta cell. Volta cell is represented like this: Zn electrolyte H2SO4 and copper. In that case, if external EMF is slightly less than cell EMF, the cell reactions are like this. That is, at oxidation, at anode, that is oxidation of reaction, the reaction is that is oxidation half reaction, and reduction of reaction is that 2H plus in aqueous state. Ions are always in aqueous state in electrochemistry, that is gives H2. In this case, H2 gases evolve, and the cell reaction is that like this, gives Zn2 plus aqueous plus H2 gas. Second condition is that if external EMF is slightly greater than cell EMF, the cell reactions are like this: Cu2 ions plus 2 electron. Oxidation, this is oxidation of reaction, and reduction of reaction is that like this. In this case, H2 gas is also pure. Therefore, the overall cell reaction is that like this. Copper, that is solid copper plus hydrogen ions gives copper ions in aqueous state plus H2 gas. If we look at these two reactions, these reactions are not reversible to each other. Therefore, this cell is called as irreversible cell. In this way, we can explain reversible and irreversible cell. From the examination point of view, you have to ask the short note about reversible in combined reversible and irreversible cell. You have to say, first of all, you have to say the conditions of reversible cell, and in irreversible cell you have to mention only the cell which does not satisfy the above conditions are called as irreversible cell, and explain it with. We take the example that is in reversible cell, we take the Daniell cell, and in irreversible cell we have to take the example particle cell. Thank you.